Hello and welcome. Let's solve another interesting question on shear force and bending moment. Alright, the question says we should draw the shear force and bending moment diagram for the simple supported beam loaded with a concentrated force P, which is what, 100 kilonewton, and a concentrated moment MC, which is what, 200 kilonewton meter, as shown below. You can see this is the diagram. This diagram is given to us. All right. Now, but this reaction here was not given to us. Let me just explain this. Now, if you have a rolling support has just direction in one axis, and that is the x axis, that is the horizontal axis. So there's no movement in the vertical axis. That is why we are going to have our reaction and in the vertical axis. All right, this is a pin support. If we have a pin support prevents movement in both direction. So we are going to have our reaction in vertical axis and our reaction in the horizontal axis. But here we don't have any horizontal force. That is why we neglect that. So now it means we are going to have a vertical reaction here and a vertical reaction here. All right. So now the next thing we are going to do now is to calculate the reaction at support A and the reaction at support B. And how do we achieve that? We know that the sum of upward forces will be equal to the sum of downward forces from equilibrium. All right. So now it means that we are going to have reaction at A plus our reaction at B to be equals to what? To be equals to 100. So we'll call this our equation number Equation number 1. All right. The next thing we are going to do is we are going to take moment. We are going to take moment. That is the sum of moment. All right. You can decide to take this moment about point A or about point B or about point C. Any direction you wish to take your moment, you are free to do that. All right. But for the purpose of this class, I will take my moment about point A. So we are going to say the summation of moment about point A should be equals to 0. All right. So now if we are taking our moment about this point, it means moment about this point will be 0. So now we are going to take our moment about this. So we are going to start from this here. Here we have an upward force here, and if we are taking our moment, we can decide to give coordinate, that is direction, that our upward force should be positive and our downward force should be negative. All right. So now, what do we mean by our upward force positive and our downward force negative? The meaning of this is this: if this reaction here is moving up, it's going to move in this direction. It's going to move in the anti-clockwise direction. So take note, when we say that upward force positive, it means anti-clockwise moment is positive. And when we say our downward force is negative, it means that, look at this, our downward force is going to produce a clockwise moment. So which means that it means that our clockwise moment is going to be positive. Is going to be negative. Is that clear? All right. So now, if we take our moment about this point, we are going to have, we know that moment is force times perpendicular distance. So this is our force here times the total distance. So it's going to be R subscript B multiplied by 4. All right. And the reason why it is positive there is because we have already given direction that upward force will be positive. All right. So here we are going to have a downward force here, which is 100. So it's going to be 100 multiplied by by 2. So minus 100 multiplied by 2, because it is a downward force. But don't forget, we have a moment here moving in this direction, and it is moving in anti-clockwise direction. So, and don't forget, we said our upward force is going to produce a anti-clockwise direction, which is positive. It means this anti-clockwise moment here is also going to be positive, because it's a moment, and what we are doing here is a moment. We are going to add that to this, so it's going to be a positive plus plus 200 kilonewton meter. Please, it is a moment, so we don't need to take distance. This is already a moment. All right. So everything here is going to be equals to 0. All right. So now, if we continue with this, 4 times ROB is going to give us 4 ROB minus 100 multiplied by this is 200 plus what? Plus 200, which is going to be equals to 0. So this will cancel out this. We are going to have 4 RB to be equals to what? 0. So if we divide both sides by 4, RB will be equals to what? 0. Alright. So we can therefore calculate for our what? RA. At this reaction at A. So we are going to have from equation 1, we have RA plus RB to be equals to what? 100. So if our RB is 0, we are going to have RA plus 0 to be equals to what? 100. So it means that our RA will be equals to what? 100. So this one is going to be what? Kilonewton. The unit of these two is going to be what? Kilonewton. Alright. Now that we have calculated our reaction at A and B now we can now calculate the shear force calculation and the bending moment calculation. Alright, let's start with the shear force calculation. Alright, so if we say shear force, what do you mean by shear force? It's just the algebraic sum of forces either to the left or to the right on our beam. Exactly. Alright, so now we are going to start as shear force at point B. This shear force at point B. Alright, the shear force at point B. Now, if you stand here how many force can you see? To your what? To your right. So if you say how many force can you see to your right, you are going to have just only this force, that is RB. We don't have any force again except from this. So and under this our shear force moment calculation, we are still retaining this rule here: upward force positive, downward force negative. So it means that our reaction here, which is B, is going to be what? 200. Sorry, RB is what? 0 rather. So it's going to be 0, not 200. Alright. So now let's calculate the shear force at what? At point C now. Alright, the shear force at point C is going to be what? Now, if you stand here now, how many force can we see to our what? Our right. It's just this and this, right? Alright, we know that upward force is what? Positive, and downward force is negative. So here we are going to have 0 minus what? 0 minus 100, which is going to give us what? 100, negative 100 kilonewton. This one too is going to be what? Kilonewton. Alright, so the last but not the least, we are going to calculate the shear force at point A. Alright. The shear force at point A will be equals to, now, if you stand at this point now, how many forces can you see? We can see 1, 2, and what? 3. So it means here we are going to have RB, which is what? 0, which is upward, then minus what? 100, then plus what? Plus RA, which is what? 100. So if you sum all of this together, you are going to have this to be what? 0 kilowatt Newton. Alright. Now, the next thing we are going to calculate is the what? Is the bending moment calculation. Alright. Now, if we are dealing with our bending moment calculation, we start with the bending moment at point B. Alright. Now, bending moment at point B. If we stand at this point, we know bending moment is nothing but what? The product of force and the perpendicular distance. So if we stand at point B now, we don't have distance here. We just have only this force here, no distance. So now it means that we only have ROB here. So it means, and our ROB is what? And our ROB is 0. So because we don't even have distance too, it will make our moment at point B to be what? 0. That is why most times you are going to be told that if we have a simple supported beam, what do you mean by a simple supported beam? A beam that have a support at both ends, right? So the moment at both ends of a simple supported beam is what? 0. Exactly. So it means the bending moment at point B is what? 0. So this is going to be what? 0 kilonewton meter. Alright. So now the next one is the bending moment at point what? At point C. Alright. So now the bending moment at point C is going to be what? 0 multiplied by what? 2. This is the force, and this is the perpendicular distance. That is, this to from this point to this point is 2. So this times this. All right. So it's going to be 0 multiplied by what? 0 multiplied by 2. All right. But don't forget, at this point, see again, we also have a moment, which is what? 200 kilonewton meter. But don't forget, we are still working with this rule here: upward force positive and downward force negative. And we said our upward force give us a what? Anti-clockwise moment. So which means anti-clockwise moment is also what? Positive. So now, and this moment here is also what? Anti-clockwise, right? So it means it's going to be what? Positive. So because it is moment and we are dealing with moment at point C, so we are going to be adding this to that, because anti-clockwise moment is taken to be what? Positive. All right. So we are going to have plus what? Plus 200 here. So now 0 multiplied by 2 is 0. Plus 200 is going to give us what? Plus 200 kilonewton meter. All right. So now the next thing is we are going to find the bending moment at point what? At point A. So we are going to say bending moment at point A will be equals to, now bending moment at point A here is this. If you stand here, we are going to have ROB. Our ROB is 0 multiplied by total distance, which is what? It's going to be 0 multiplied by 4. And if you come here, this is an upward force, which is taken to be what? Positive. So down here we are going to have minus what? Minus 100 multiplied by what? By 2. Minus 100 multiplied by 2. All right. Now, and this is our anti-clockwise moment. Our anti-clockwise moment is what? Positive. Because we are given that upward force should be what? Positive. And we know that if we have an upward force, it means we are also going to have a what? Anti-clockwise moment. All right. So this is going to be what? Plus what? 200. Plus 200. We have to consider that. All right. So now this is going to be equals to what? This is going to be equals to 0 multiplied by this. That's 0 minus 100 times this. That is 200. Plus what? Plus 200. So if you do this, we are going to have 0. So you can see that the bending moment at the both end of a simple supported beam is nothing but what? 0. So most time when you have a simple supported beam, you don't need to calculate for that. Is that clear? You can just, because we already know that it's going to be what? 0 at this end. So you can just focus on what is inside for the purpose of exam to save your time. But if you have the time, you can do that. All right. So now, the next thing we are going to do now is to draw the shear force and the the shear force and the bending moment diagram. So I'll be doing that at this point. All right. So if you have been following our video, we have already taught us how to draw the shear force and bending moment diagram. So we encourage you to watch our first video, that is the introduction to bending moment and shear force. But let's do this. So for us to do this, the first thing we are going to do is every point that we have load, that is we have force and the reaction, we are going to trace a line down. So from this point, I'm going to draw this point down. All right. So here too, we are going to have a line. All right. So here too, we are going to have. All right. So we are going to need to draw our reference line for. I've already said from our introduction class that the length of our bending moment must be equal to the length of the what? Of the beam. So we are going to have this place, this place. All right. Now, from this point is going to be 0. This point 2 is going to be 0. Point here is going to be 0. This point here is going to be 0. So this line here is the reference line for our what? For our shear force diagram. This line here is the line for our is the reference line for our what? Bending moment diagram. All right. So now you need to note that anything above this line upward is a positive line, and anything below is a what? Negative. All right. So now let's start with the drawing. Now we said this point is B. The shear force at point B is 0. So this is 0. This is point 0 here. All right. So now if you move from B to C, we don't have any force. So it means we are going to draw a straight line since this beam is just having a what? A point load. All right. So now it means we are just going to draw a straight line which is already there. So to this point here. Is that clear? All right. And if you get to point C, we said that the shear force at point C is what? Negative what? 100. Is that clear? So it means from this point to this point. So from this point now we go down 100. Is that clear? We have a negative answer there, so it's going to be negative 100. So let's just stop here. Let's pick here to be our 100. All right. So now we are going to use a straight line to represent that. All right. So now this is our 100 here, negative 100. So now if you look at our shear force at A is what? 0, right? But now if we draw this one, the shear force at C is what? Negative 100. So from this point to this point is 100. And if you check between C and A, we don't have any force there, right? We don't have any force. So it means we are going to use a straight line to represent that. This is going to be constant. So we are going to have a constant line here. All right. So now then we said our shear force at point A is what? 0. So it means this line is going to go back to what? 0. All right. So it means that this line here, this one here is what? Is negative. And this point here is just like this straight line, then like this. So here, let's just indicate. We have negative 100 here. Kilonewton. And here we have 0. So from here to here 2 is still what? 100, because it is what? Constant. So here 2 we are going to have negative 100 because it is constant. All right, negative, let me just put it here. 100 then to 0. All right. So now let's draw the bending moment diagram now. All right. So the bending moment now, the bending moment at point B is 0. All right. So at point B is 0. This is point 0 here. All right. So now, and then the bending moment at point C is 200. Now, from point B to point C, we don't have any moment here. So now what we are going to do is this. We are going to use an inclined line now to connect point 0 to what? To point C, because it's our point C and we have a positive word there, 200, right? So it means I'm going to connect this point to this point here to be what? 200. We can just pick any line here to be what? 200. So it means this one is going to be like this. Draw an inclined line here. All right. So this is 200. All right. 300 kilonewton meter. All right. Then now, the bending moment at point A is what? Is 0, right? So we are going to connect. So you know, I pause here because I noticed that this is what most students is going to do here. This is not correct. If you do this, you are going to get it wrong. All right. So, you know, if you move from, we are on a normal day, you're supposed to move from 0 to what? 200. This is what most students is going to do. And this is very, very what? This is very, very wrong. Don't do this question in this way. All right. So the right way to do this question is this. Now, we have our bend moment at point B to be what? 0, right? Now, don't forget that we have two bend moments at point what? Point C. First one is going to be the one from this point to this point that we calculate, which is 0 multiplied by 2. Is that clear? Now, this, let's assume that we don't have this moment here first. So let me clean what is here. All right. So now let's revisit this again, because I want you to get this concept clearly. All right. Now let's assume that we are not given this moment that is here. Let's assume that it is not there. All right. I will not have had this 200 here, right? If it is not there, right? Now let's assume that this moment is not here too in your own side there. So what we have here is just 0 times 2, which is what? 0. Now, so it means that we are going to move from the moment at point C is going to be what? From 0 to what? 0. And we cannot draw an inclined line here. So the line is going to be what? Constant. Is that clear? So it means from this point here to this point is going to be what? 0. All right. So now, if you now look at this now they now had this bend moment now. This moment for us at this point what? Point C. Is that clear? Now, if you now add the effect of this bend moment given to us to what is here, it's still going to be what? 200, because 0 times 2 is 0 and 0 plus 200 is what? 200. So the meaning of that is, it means that at this point C, we have 0. It means the bend moment increases from 0 to what? To 200. Is that clear? So it means it's going to increase from 0 to what? To 200. So let's put 200 back here now. So this is 200 kilonewton meter. Is that clear? So please, this is the approach you should always use when you have a what? A bend moment. Don't worry, we still have more example on this. We are still going to solve up to 2 or 3 examples on this. So you are going to get it clearly. The more you keep solving difficult problems, the more the understanding. Is that clear? All right. So now let me go over this again. We have our the original moment. The original moment at point C is nothing but what? 0 multiplied by what? By 2, which is what? 0. Is that clear? Now they now had this moment. Now, do you understand? And now when you say 0 multiplied by 2 plus 200, the answer there is what? 200. So it means your bending moment there increases from 0 to what? To 200. Is that clear? Now we now have our bending moment at point A to be what? 0. So it means at this point we have 0. So it means that we are going to connect this point now of 200 to this point now. So now we are going to have an inclined line here now. So now we are going to connect here. All right, so we are going to have this. All right. So this is positive. So if you want to shade, you can shade all this space. All right, so here is the solution to this question. I believe you understand this. So stay tuned for more questions.